Hey again, welcome to Chem Classroom with Aunty Taiwo. In the last video, we spoke about chemical equilibrium. We were able to define chemical equilibrium, and we listed and explained the factors affecting chemical equilibrium, starting from the temperature, the pressure, and the concentration. And I also emphasized that catalyst does not affect chemical equilibrium. So today we'll be solving a practical question on the board. And before we leave, I would like to state the Chatelain's principle, which is the principle that we'll work with for chemical equilibrium. And it states that when a system is at equilibrium and there's an external force or external factor, the equilibrium will shift to neutralize the effects. So we'll be solving a question on the board. Now let's go. Okay, consider this equation. We have iron reacting with steam to produce that on the board. So we are being asked to write the equilibrium constant as the first thing. The last time I did an example in that regard. So for the forward reaction, if we're going to write the equilibrium constant, we have to put the product over the reactant. So we have equilibrium constant Kp. Here I have what? Fe3O4 in square brackets. Then I will write another square bracket for hydrogen raised to power of what? 4 over, I have my iron raised to power of 3. Another square bracket, my steam H2O raised to the power of 4. So we are done with that. Okay, then moving to the second question. Decrease in temperature. Now, the last time we emphasized that when it comes to temperature as a factor, you need to consider if the reaction is endothermic or if the reaction is exothermic. Yes, and this reaction now is what? Exothermic. And I told us that it is through the delta H that we'll know what reaction it is. Now our delta H is negative, so that means the reaction is what? Exothermic, whereby it is liberated to the surroundings. So what will happen here is that decrease in temperature is going to what? Favor the forward reaction. So it's going to favor the forward reaction. So that means the equilibrium will shift to the what? To the right hand side. Decrease in temperature will favor the equilibrium to be shifted to the right hand side. Then increase in pressure. Now I have to rewrite the equation for us to emphasize on that. Okay. Now we'll be working with the number of moles behind each of the reactant and the product. So for iron, I have 3. For water, I have 4. So I have 7 here to be what? To be the pressure here. Then for the iron, I have 1 plus what? 4 to give me 5. So I have 7 on the reactant side, I have 5 on the product side. So if there is going to be increase in pressure will definitely favor this side that has a lower pressure, because I have 5 here. So I want to do something to balance up with this 7. So increase in pressure, the forward reaction will be favored. The forward reaction will be favored. So now moving to the last one, moving to the last question, it says that removal of hydrogen. Now look at the reaction. If hydrogen is being removed here, more of the reactant, which is your iron and your steam, will react together to form more of the products. Okay, so we have been able to solve a practical question for an exothermic reaction. So when next we meet, we'll solve another practical question for endothermic reaction, and we are going to see the difference. Okay, so please solve more questions on your own. If you haven't, click on the notification or on the subscription button, kindly do so, and click on the notification button so that anytime we upload our videos, you get to see them. All right, see you in the next class. Thank you.